Okay, so AB 2018 number 4, they give us some data about the height of a tree. And we know it's a twice differentiable function, and h of t is measured in meters and t is measured in years. Okay, so twice differentiable, we should be thinking at some point we might have to use a mean value theorem or something. So let's look and see. Use the data to estimate h prime of 6 and using correct units, interpret the meaning in the context of the problem. Okay, so if we want h prime of 6, well, we have at 5 and at 7, so we might as well use those two values since 6 is right in the middle of them. So we can say h prime of 6 is going to be approximately equal to h of 7 minus h of 5 over 7 minus 5, average rate of change. So 11 minus 6 over 2, 5 over 2, and remember h is measured in meters and time is measured in year. So the approximate rate of growth of the tree at time equals 6 years is 5 over 2 or 2.5 meters per year. Part B. Explain why there must be at least one time between 2 and 10 such that h prime of t equals 2. Well, since h is twice differentiable, it's continuous, and since it's differentiable, the mean value theorem holds true. And since the interval 3 to 5 is a part of the interval from 2 to 10, by mean value theorem, h of 5 minus h of 3 over 5 minus 3, which equals 6 minus 2 over 5 minus 3 equals 2. Therefore, there exists a value, some value c, on the interval from 3 to 5, where h prime of c equals 2. Got to have mean value theorem in there, okay? Got to state MVT. Can't just show the math work, got to state MVT. Part C, a trapezoidal sum, first 4 subintervals, to approximate the average height of the tree. Average value of the function, remember it's 1 over b minus a, and then do your trapezoidal sum, because the average value is 1 over b minus a times the integral from a to b. So 1 over 10 minus 2, and there's our trapezoidal sum, 1/2 the first delta x times your 2 y's, plus 1/2 the second delta x times the sum of the 2 y's, and 1/2 the third delta x times the sum of the 2 y's, and then 1/2 the fourth delta x times the sum of the 2 y's. Adding it all up, again, originally this was a no-calc question. You will have a calculator, and there we go. We get 131.5 over 16, or if you look at the answer key, you just double the top and the bottom. That's 263 over 32. Now, part D. The height of the tree can be modeled by that function, where x is the diameter of the base of the tree. When the tree is 50 meters tall, diameter of the base of the tree is increasing at a rate of 0.03 meters per year. So that's dx dt. According to the model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? So if the tree is 50 meters tall, first thing we have to find out is when g is 50, what's x? So we solve for x and we get x equals 1. So now we do our derivative with respect to time, related rates, okay? d dx of g of x equals, we're going to have to use a quotient rule. 1 over x times 100 dx dt minus 100x times the derivative of 1 plus x is dx dt, all over 1 plus x squared. Well, on the top, we can factor out a 100 dx dt, and that leaves us with a 1 plus x minus x. So that really gives us 100 over the 1 plus x squared on the bottom times dx dt, because the x's cancel out there, and you could write it as 100 with the dx dt on top. That's fine. So now we sub in dg dt is 100 over 1 plus 1 quantity squared times the 0.03. So 100 over 4 times 0.03 gives us 3/4 meters per year. Okay. Again, a question where they put a lot into one question: average rate of change, mean value theorem, trapezoidal sum, excuse me, and related rates. So this, I think this is a good question that could be used on this year's exam.